Gosh, we've got a lot to go through today. I'm going to go through some basics, and then afterwards, given time, I've got a little bit of a magical mystery tour where we dive in deep, and I'm going to tackle a few problems very close to my heart. One is the beauty and horror of AI, and the other one is on digital sovereignty. Can I ask who here has heard of my mapping beforehand? Can you raise your hands? Okay, a few of you. And how many of you actually use it? Okay, and how many of you, this is completely new, you have no idea what I'm going to talk about? Most of you, fantastic, right, super duper. Okay, so X marks the spot. I'm going to talk about the origin of how I got into the subject of strategy, and then I'm going to talk about how I got into maps themselves, and then I'm going to use this to talk about patterns that we discover using maps. Then I'm going to talk about change. And then afterwards, I'm going to talk about gameplay and eventually finish off with X marks the spot. And we're going to do all of this. And if we get to the end, we can either do some Q&A or we can deep dive into those two topics I talked about. So the origin. This all started for me many, many years ago, back in 2003, 2004, 2005, when I was working for this company, for Tango. It was an online photo service with 16 different lines of business, very profitable. I had a big problem, though. The problem was the CEO. Our CEO was completely and utterly hopeless. They had no idea what they were doing. They were making stuff up as they went along. Now, I know this for a fact because I was the CEO. I used to come up with these wonderful statements about the future. So our strategy is customer focused. We will lead an innovative effort in the market through our use of agile techniques and open source. But I'd literally borrowed this from another company and just changed a few words. I mean, we were heavy users of extreme programming. I know Kent Beck. Kent's somewhere here. I don't know where. He's somewhere hopefully in the audience. So we'd adopted extreme programming. This was back in 2000, just before the Agile Manifesto came out. But anyway, this was just copied from another company. And I used to read every book I could find on strategy. I was getting nowhere, didn't understand any of it. And I was really worried somebody would rumble that I was making stuff up. So I ended up in a bookshop in Charing Cross in London. And I was talking to the bookseller, and she asked me, had I ever read The Art of War by Sun Tzu? And I hadn't. So she persuaded me to buy two different versions of the book. She was a fantastic bookseller. But I'm also very grateful, because they're all translations. And it was in the reading of the second translation that I realized there was a pattern. So Sun Tzu talked about 5 factors which mattered in competition. 1, have a purpose, a moral imperative. 2, understand your landscape, the environment that you're competing in. 3, understand the heavens, the climatic patterns, the weather, how the landscape is changing. Then you get into principles of how you organize yourself, the collection of which are called doctrine. And finally, you get into things like gameplay and the areas of leadership. And I was fascinated by this. And at the same time, I came across the mad major, John Boyd. Has anybody ever heard of John Boyd? Hands up, a few of you. Well, John Boyd created something called the OODA loop. He was a former US Air Force pilot. And the OODA stands for, the first O is to observe the environment. And that's what landscape and climatic patterns are about. Then you orientate yourself around the space. That's what principles and hence doctrine is about. And finally, you need to decide where to attack, and then you act. Now, I was fascinated by this sort of combination of Sun Tzu and Boyd and this strategy cycle. And it got me thinking about how do I observe the landscape I'm operating in. And that's what got me into maps. Now, I started reading lots and lots into military history. And I noticed how in military history we use maps to learn from one battle to another battle. So this is Themistocles, ancient politician, Greek general. This is ancient Greece, independent city-states. They had a problem. The Persians were invading. Now, there's about 140 to 170,000 Persians. We don't quite know how many. And Themistocles had, choices. He could defend around Thebes, defend around Athens. What he decided to do was to block off the Straits of Artemisium, force the Persians along a narrow pass into somewhere called the Hot Gates. That's literally what Thermopylae means, Hot Gates. It's a narrow pass. Now here, a small number of troops, and there were about 4,000 Greeks, could defend against a much larger force. And in those 4,000 Greeks, there were 300 Spartans. Yes, that's where we get the story of the 300 from. Now, I was fascinated by this. I was looking at this map and thinking you could use it to discuss, defend around Thebes, what should we do? And I started looking at how I was making decisions. Now, I was using something called a SWOT diagram. Have you ever heard of a SWOT, anybody? Yes, right. Stands for strengths, weaknesses, opportunities, and threats. So I decided to create one for this battle. So strengths, a well-trained Spartan army, a high level of motivation not to become a Persian slave. Weaknesses, the ephors might stop the Spartans turning up. A truckload of Persians are turning up. Opportunities, get rid of the Persians, get rid of the Spartans. We're actually Athenian. We hate the Spartans. And the threats, the Persians get rid of us. And the oracle says a really dodgy film might be produced a few thousand years later. So I asked myself, what would you use to communicate and determine strategy in battle? A magic framework like a SWOT diagram or position and movement described on a map. What would you use? SWOT or map? Map. What was I using? SWOT. Okay, so at this point I thought I really need to understand the map of my business landscape. So I went back into my organization and said, send me all your maps. I want all the maps you've got. And I got sent customer journey maps, business process maps, mind maps, loads of mind maps, and systems maps. And I took one of these systems maps, and this is CRM, one of the components stands for Customer Relationship Management, and I simply moved it on the map. Now, how has that changed? Any ideas? Well, it hasn't. If I took a map and I say, move, I don't know, Denmark, and put it next to the United States of America, has that map changed? So why hasn't it changed here? And the answer is, because it's not a map, it's a graph. The only thing that all of these maps had in common is that none of them were actually maps. They're all graphs. So to give an example, here's 3 locations in the UK, Nottingham, London, Dover, connected by 2 roads, M1, M2. Now, if I move Dover, it's still the same graph, because it is a graph, it's not a map. In fact, all these 3 graphs at the top are completely identical. Same nodes, same connections, same weighting between them. Now, the 3 maps at the bottom are completely different. And they're different because we've got a compass. And the net effect of the compass is to give space meaning. And that's the difference between a map and a graph. In a map, space has meaning. So you can't just randomly move things without changing the meaning. Now, in order to give space meaning, you need an anchor. That's one thing, such as magnetic north. You need the position of pieces. This is north, south, east, or west of this. And you need something known as consistency of movement. So if I'm going south, I'm going south. If I'm going southwest, I'm going southwest. I'm not going north. So there's no teleportation. If you have those components, you can describe a landscape. So I thought I need to do this for my business. Now, my business was an online photo service. That's a bit boring, so I'm going to do a cup of tea because it's really simple. So what's my anchor with a cup of tea in a, say, tea shop? Well, I've got hopefully the public who wants to consume cups of tea, and I've got the business who wants to sell cups of tea. Okay, so that gives me an anchor around the business and the consumer. I could also use regulators as well. I could use shareholders, lots of other anchors. You're not limited to having one. Okay, now what does a cup of tea need? Well, it needs tea, it needs a cup, it needs hot water needs cold water, it needs a kettle needs power. So what I've got is a chain of needs. So this gives me position. And the further I go down the chain, the less visible components are to things higher up the chain. So to the public, the cup of tea is very visible. The power that I use to heat the kettle, essential though it is somewhat far removed. All right, this is still a graph. I now have to think about how do I add movement to this. Now, movement in geographical terms is fairly easy, because if I'm going from Thermopylae to Thebes, I go southeast. And during that journey, Thebes is unlikely to move. However, if my journey took 200 million years, it may well have moved, okay? So the question we have to ask is, what is the landscape of business, and are there tectonic plates? So the landscape of business, it turns out, is capital. So activities, practices, data, knowledge, what we call resources. Now, do they move? Well, this is power. This is power with the Parthian battery. And 1,400 years after the Parthian battery, this is power again, but Tesla and Westinghouse, it's a utility provision of electricity. So yes, it moves slightly faster than 200 million years, but not too bad. It's still 1,400 years. The problem is today, this is computing. The Z3 in 1943, I should say, and that's Amazon EC2, so utility provision of computing, some 60 years later. 60 years is a lot faster than 200 million, which means that as things evolve and change, it's like Thebes moving, just a few hundred meters, maybe every day. So I had to ask the question, what if we describe movement through change itself? And this piece of work took about a year. It turned out there was a pattern by which capital evolves. We start off with the genesis of the novel anew, custom-built examples, products, and then rental services, and eventually commodity and utility services, all driven by supply and demand competition. So if you think about the Parthian battery, that's the genesis. Then you get custom-built systems like the Hippolyte Pixie. You get Siemens generators, eventually Tesla, Westinghouse, utility provision. Or you think about the Z3, 1943, custom-built systems like Leo Line's electronic office. Then you get the first products, IBM 650, rental services like Timshare, then commodity hardware, and then eventually cloud. It's just utility provision. So it turns out it didn't matter whether I was talking about penicillin or money or computing or whatever it was, they all evolved through a common pattern. Okay, so what I can do is take that pattern and put it at the bottom. Genesis, custom-built, product, commodity, and I can simply go through my graph and say how evolved are these components. And now I've got anchor, position, and movement, and this is a map. And that was one of the first maps I did in 2005. Now, what I'm doing here is I'm exposing to you my assumptions about how to build a tea shop. And you can look at my assumptions and go, so what? Why does that matter? Well, you can challenge them. You can say, why have you got kettle and custom built? Surely that's more of a commodity. Where's the staff? Where's your billing mechanisms? How are you actually going to create revenue? Now, most organizations, we run on stories. And unfortunately, we tell people that great leaders are great storytellers. And that creates a problem. When you challenge somebody's story, you're challenging their leadership ability. And that's why people get very, very defensive. If you put the story in a mapping form, you can challenge the map without challenging the person. You say, I think there's something wrong with the map, not something wrong with the person. So I'll give an example of this. An insurance company. This is about 2011-ish, something along those lines. They needed compute, order server goes into goods in, modify, mount, and rack it. They had a bottleneck with the modification and mounting and racking of servers. Now they're rapidly growing, so they decide they've got to fix this problem, and they decide they're going to use robotics to do so. They spent 6 months working on this. They had a team looking into this particular space. They built an entire business case. They had multiple vendors come in and make various offerings. They had eventually an entire financial model, return on investment calculation, sub 1 year, all ready to go. Now, I was asked, can I have a look at this problem? Problem is, I can't challenge the story. I can't go in, why are you building robotics? They'd be all like very defensive. I mean, executives, we like to say we like challenge, but what we mean is we challenge you, not you challenge us. So I said, well, can we turn this into a map? And they went, oh, no, I don't see the point of that. We spent 15 minutes arguing. And then after that, we spent 15 minutes creating the map. And this was the map. A user needs compute order server, server goods in. They had all the sort of order server, server goods in, very commodity. For some reason, they had compute more product. Oh, it was 2010. And then they had rack mount modify. Anybody want to shout out a comment on that map? Why? What are they modifying? Yeah. Good comment. They're modifying servers. Anything else anybody wants to notice? Why is rack custom built? That's what I asked. Why you've got rack in custom built? They had custom built racks. So they're an insurance company. When they started using compute, there weren't such a thing as standard racks, so they had custom built racks. And so they'd continued this, and they had custom built racks. And then I said, what are you modifying the servers? And they said, the servers we buy don't fit our racks. So we have to take cases off, drill new holes, add new plates in order to get them to fit our racks. And then somebody in the room just went, why don't we use standard racks? Now, this is multi-million pounds saved by that, okay? These people were not stupid, they were not daft, they were simply trapped by past narrative. That's all. As soon as they could see it, they realized that what they'd been doing is optimizing process flow rather than thinking about how things actually evolve within the system. And this is incredibly common. Now, one of the things I use maps for is learning patterns. So pre-mortem challenge, we'll map something out, and we'll use that to get everybody's ideas and challenge what we're doing. And then we'll go and do it. And afterwards, we'll do post-mortem learning. And from that, we learn various patterns. So I'm going to show you some. This is HS2, high-speed rail, big, heavy engineering project. This is James Findlay, the CIO for HS2. Now, James had a problem that he needed to build the entire railway in a virtual world. This was about 2012. And the reason why you build the railway in a virtual world is it's easier to dig up a virtual world and go, whoops, we've got that wrong, than the English countryside. So this is a graph, not a map, a graph of HS2 building in a virtual world. And the way we used to deal with this in government at the time, we'd break it down into small contracts, because small contracts were good, and then we'd outsource them all. So we'd break it down into like lot 1 engineering, where all the engineering things would go, and lot 2 user experience, and lot 3 back office, and we'd outsource them. And these would invariably have a massive cost overrun, massive failure rate. So James decided he would do something different. He spent Sunday afternoon and he mapped it out. And he sent that map to me and said, right, how do you manage something like this? Now, for me, this was quite easy. I'd learned some time ago that as things evolve, their characteristics change. They go from this uncharted space, being highly uncertain, the genesis of something, to being much more industrialized, known, standard, boring, dull. And because of that, there was no such thing as one-size-fits-all methodology. So I had adopted extreme programming throughout my entire organization in 2000. By 2002, I discovered it doesn't work everywhere. What I'd learnt was that agile extreme programming is extremely good on the left-hand side because it reduces the cost of change and changes the norm. But on the far right-hand side, Six Sigma and outsourcing works best because what you want to do is reduce deviation. And in the middle, then lean, so things like Scrum work better because you're focused on learning and reducing waste. So there's no such thing as one-size-fits-all method. Same with purchasing. So on the left-hand side, it's much more time material based. On the right-hand side, it's much more unit utility, and in the middle, more COTS. Same with financing. So we simply apply that to a map. The left-hand side, we're going to build in-house agile techniques. The middle stuff, we're going to build off-the-shelf products or use off-the-shelf products. If we're going to have to build, we use something like Lean. Stuff on the right, we're going to outsource, unless we have to build, in which case we're going to use something like Six Sigma and wonder why there isn't a utility service. So what we learned to do was use appropriate methods. Okay, there is a world of difference between using Agile, like extreme programming, and being Agile. Being Agile means using appropriate methods. That includes Six Sigma and all those other techniques. Of course, if you turn up to an Agile conference and say that, they will go, burn him, heretic. Likewise, if you go to a Six Sigma conference and say, no, it doesn't work everywhere, burn him, heretic. All right, so let's take one of those original contract structures, Lot 1 engineering, and let's apply it to the map. That's what it looks like. Now, I can tell you this contract's going to fail before we've even signed the paperwork. The reason why it's going to fail is the stuff on the right can be specified and the stuff on the left can't be specified. So it's always going to lead to cost overruns. And what's going to happen if you do this is you end up with a fight with the vendor. The vendor said, look, we delivered all of this stuff, but all of that stuff, well, you didn't know what you really wanted. It's all your fault. No, it's the method that we used. Of course, the worst thing that happens is somebody on your own side says, next time we need to specify it better. Fire them. All right, so using this approach, we save various projects. One project alone, we save 425 million, about 1.5 billion in its lifetime, simply by mapping it out and using appropriate methods. I mean, the HS2 one ended up in front of the Public Accounts Committee because it was delivered way under budget, way ahead of schedule. And this stuff isn't being used just in government. This is carbon mapper satellites, which was put up by NASA working with Planet Labs, and between them, they coordinated in the background using my form of mapping. Okay, I just want to show that you've learned that pattern by using what I like to call the Elvish self-driving car. So I've taken a system graph for a self-driving car, and I've translated it all into Elvish. Does anybody speak Elvish? Good, right. So basically, everybody in finance, IT seems a bit Elvish too, and everybody in IT finance seems a bit Elvish too. So I'm going to pretend I'm IT and you're finance, and I want you to help and work with me and collaborate with me, spirit of collaboration and cooperation. I need some advice. ABC, which bits should we outsource? I'm working with you. All of them. All of them. Right, fantastic. All right, let me show you it again, exactly the same thing, but in mapping format. A, B, and C. Right, A, should we build our own? What should we do? Right, B, should we build our own? Yes, right, C, what should we do? Off-the-shelf product, maybe. All right, so as simple as that. There are three basic types of patterns you learn: climatic patterns, doctrine, and leadership. Leadership have various forms of stratagems or gameplay. There's about 150 of those. Principles, you've just learned one principle, use appropriate methods. Actually, I've sneaked in several others, like focus on user, understand the user needs, understand the components, the supply chain. Climatic patterns, these are the rules of the game, and that's useful for anticipation and change. So here is roughly computing in 2005. User needs an application built on best coding practice, on a runtime, on an operating system, on best architectural practice, on compute as a product. Roughly 2005. The first pattern you learn, climatic pattern, is everything evolves. If there's supply and demand competition, it moves from left to right. Okay, so we knew compute was going to become a utility-like service. I thought it was going to be Google. A friend of mine, Ben Black, was actually in AWS at the time. He proposed EC2 to Jeff Bezos in 2003. Chris Pinkham and others built it in South Africa as a standalone service. Basically, a friend of mine, Jesse Robbins, who ran AWS's data centers, he was the master of disaster, said, "You're not having that nonsense anywhere near us." You often hear people say they were selling spare capacity. Total garbage. It was built as a standalone service. All right, so everything evolves. The next pattern you learn is we have inertia to change created by past success. So Blockbuster, Netflix. Who was first with a website? Blockbuster, yes. Who was first with video ordering online? Blockbuster, yes. Who was first with video streaming experiments? Blockbuster, yes. Who went bankrupt first? Blockbuster. Okay, so the problem with Netflix was a DVD mail order company. The problem Blockbuster had is its pre-existing business model, which was based on late fees. So you used to go and get a video cassette, take it home, forget to bring it back the next day. And every time you forget to bring it back, they made extra money. And of course, that depended upon having physical stores. So despite the fact they out-innovated everybody, they had huge amounts of inertia to change because of their pre-existing business model. That can often be a killer for organizations. Right, the next pattern you learn is coevolution. So as things evolve, the characteristics change, so you get a change of practice. So compute, we used to have what's called high MTTR, high mean time to recovery. So when your machine went bang, it would take weeks or months to get a new machine. Does anybody remember those days? Nobody? Few of you willing to admit it used to take weeks or months to get a new machine? Yes, fantastic. Well, okay, so we're showing our age. Back in those days, because it took weeks and months, you used to do things like capacity planning. We used to, scale up. We used to do disaster recovery tests. Does anybody remember those? Yes, right, okay. So then what happened is it changed. It went to low MTTR. It now takes seconds to get a new machine. And so we distribute systems designed for failure, chaos engines. We do continuous deployment because we're not waiting for months for the machine to turn up. Eventually, those emerging practices get a name. It was DevOps. That was Andy and Patrick. Anyway, the next pattern you learn is efficiency enables innovation. So as the underlying components become more of a commodity, it enables higher order systems to appear. So you get things like Netflix video service. And those higher order systems create new sources of value or worth. Now, efficiency, speed, and new value are powerful forces. And if you're competing against somebody who's adapted, then you're under pressure to adapt. And as more change, that pressure mounts, and that's known as the Red Queen effect. So ultimately, you have no choice over evolution, which is why with cloud back in 2008, it used to be so funny. People would go, well, we have a choice over cloud. No, you don't. It was never a choice of if. It was only a question of when. All right. Now, you can use this map to try to work out where to invest. So back in 2008, I used to run strategy for a company called Canonical. Has anybody heard of Canonical? Fantastic. So we used a slightly more complex version of this map to work out in 2008, everything was going to a utility. We knew there'd be a new emerging practice. We didn't know it was going to be called DevOps. There would be new things. So we would build in those areas. And we'd also, where not to invest. We were not going to spend our time trying to make enterprise Ubuntu for the data center. We'll let others do that. In fact, we'd encourage our competitors to do that. Now, we were 3% of the operating system market, up against the likes of Red Hat and Microsoft, who had all the money and all the resources and everything else. We were small, and we had a map. 18 months later, $500,000 it cost us, we took 70% of all cloud computing. And today, Ubuntu still dominates that space. Does anybody remember, was anybody involved in cloud in those days and remember that suddenly Ubuntu came from nowhere and dominated it all? Anybody? Yeah, you were mapped. Thank you, by the way. All right. So then about 2010, eventually you got a name. Andy Patrick called it DevOps. About 2014, the runtime started to shift to things like serverless, so just a utility version, exactly the same pattern of efficiency, new practices. We didn't know it was going to be called FinOps, but we knew there would be new practices, new needs built. So if in 2016, where would you invest? It's around serverless, it's around those new practices, it's those new things built on top. And where would you avoid? Well, it's all the stuff stuck behind inertia barriers. Of course, when you look at that, you go, hang on, DevOps and cloud is in there. Yes, DevOps and cloud started the journey to the new legacy in 2016. Of course, if you turn up to a DevOps conference and say that, it's burn him heretic. The point about this is strategy is iterative. Your maps have a date. You should always put a date on your maps, as well as a perspective. So the way you play the game in 2008 is not the same as the way you play the game in 2016. You can read all about this in a wonderful book called The Flywheel Effect, which is all about an insurance company and its movement to serverless, written by Dave Addison. Lots of maps in that one. Okay, 2016. I'm going to take serverless, I'm going to take application, I'm going to take FinOps, I'm going to pretty much ignore the rest of the map, I'm going to stretch it out. So we have user needs an application, needs a coding environment, needs FinOps, needs serverless, roughly 2018, that's what you should be focused. I'm not going to worry about the nonsense underneath serverless. I don't care about infrastructure, I don't care about Kubernetes or anything along those lines, or OpenStack, even if it is still going. One thing we noticed, and we used to talk about, was how cognitive computing, for want of a better word. So AI is such a broad subject, and within it you've got NLP, you've got machine learning, and then subsets within that as well. But the overall concept, we started off with Pitts back in 1943, general problem solver, then we were getting to Watson, Alexa. We knew that something was going to become more of a utility in this space. But did it really matter that much? Well, how much were we using AI services? It became interesting when you mixed it with other things and new practices. So this is where we came up with the idea of conversational programming environments. And a friend of mine, actually, Alexander Simovich, built one of these and went and demonstrated it at AWS reInvent. So the idea of a conversational programming environment is that the process of design is a conversation between two or more perspectives, often in the heads of two different designers, sometimes in the head of one designer. And what we mean by conversational programming, and this is all based upon the work of Nicholas Negroponte and Jonna Freeman, is that one of those designers is the machine. So you're having a conversation with the machine to build something. And this is what Alexander Simovich showed at AWS reInvent. He built an AI system built on serverless, which you'd have a conversation with, and it would build other systems for you. So you'd go, I need a flight tracking system. It would ask you a bunch of questions, and you'd have a bit of a to and a fro. He actually built it so it actually used voice as well, so not just text as conversation. So if you were looking to invest, those would be the sorts of spaces you would have been focused on in 2018. And by 2023, now we have new names for them, large language models. The more interesting one is large multimodal models, and also copilots as well. Okay, gameplay. So I said there were about 30 climactic patterns. I've shown you about 5 or 6. There's various forms of doctrine. There's 40. I've shown you a handful. There's about 150 forms of gameplay. I've got 21 minutes left, so we're not going through 150. I'm just going to show you one. A very simple model called ILC, Innovate, Leverage, Commoditize. So you take a component and you turn it into a utility service. Very simple. That's the first thing you do. Like compute, you turn it to a utility service. We'll give it a random name. We'll call it, I don't know, EC2. Then what will happen is people will build on top. People will build all sorts of things on top. Some of them will build, I don't know, kitten internet. Some of them will build big data services. Now, you can't look at their data. It's their data. But you have to bill them. Billing is your data. So you can use your billing data, the metadata, to spot what is becoming interesting. And you go, oh, look, this big data stuff is interesting. So you leverage the ecosystem to spot future patterns, which you commoditize to new component services. Let's give it a random name. Let's call it, I don't know, Elastic Map Reduce. Now, everybody cheers because they can build new things, except for the people you've just eaten their business model and they grumble and blah-de-blah. All right. The trick of this game is you get everybody else to innovate for you. They're your free research and development department. Then you leverage the entire ecosystem to spot future patterns, and you basically focus on commoditizing component services and simply move up the stack doing this. Now, normally, the net effect of this is the apparent rate of innovation of the company, your customer focus and your efficiency all increase with the size of the ecosystem. So the more people building on top of you, the more of a research and development department you've got, the more data there is to leverage, and you get economies of scale. So pretty straightforward. Okay. Normally we represent it like this. So on a map, we do those like we're going to build an ecosystem around here, and then here, and then here. So you start with compute engines, you go machine learning engines, machine learning platforms, and eventually coming out with discrete services. So that was a map that was done back in, 2018. If you want to read more about this, this is Amazon AWS's second ever book, as far as I'm aware, as in their own book. There's 17 pages of my mapping in there, including that ILC model itself. Describes basically how you tear up industry after industry. So X marks the spot. Very simple. Number one, know your users. Start there. Secondly, know the details. Understand your supply chain. Thirdly, understand what is being considered. So you think about the components and you think, how evolved is this component? There's a world of difference between a commodity and something that's custom built. Now, once you've got a map of the space, you can apply some basic economic patterns. You can say everything evolves. So what happens when this evolves from a product or more of a utility? You can think about the inertia that you and your competitors will have. You can think about how it will create new practice and enable new things to appear, and you can think about how those new things will create new sources of value. Once you've done that, then you can start talking about where to invest, and most importantly, where not to invest. Once you've decided that, and you've got an idea of the landscape and how it's changing and where you could invest, you start looking at how do you manipulate the space to your favor. And once you find something that you can manipulate, and there are many tools, open source is a great way of industrializing stuff, and you can do it for various reasons. You might want to do it, you're against a competitor, it's their core business. So if you open source in their space, it'll drag their focus onto that, whilst you can focus somewhere else. So often you'll mix multiple players together to attack a space. And that's it. I started with the origin, how I got into this whole question of strategy. Then I talked about maps and the difference between a map and a graph. And then we talked about patterns, the different forms, the climactic patterns, the principles of how you organize yourself, and finally into gameplay. Talked specifically about how you use the climactic patterns to anticipate change, and then you can add gameplay to make sure that any change is to your advantage, and then just wrapped it up with X marks the spot. Did that make sense to everybody? Yes? It's easy. Really is easy. All right, the most important lesson, however, is just challenge assumptions. That's the first thing you learn with maps. The reason why we get everybody to map is get out of a story world, get all those ideas down on a map that we can challenge without challenging the person. Okay? My name is Simon Wardley. Thank you very much.